Ever wonder how drones could see the invisible? Like spotting hidden moisture in walls or sensing cracks no human eye could catch. Today, we're diving into how cutting-edge imaging tech is turning drones into high-tech detectives. Let's break down the science behind hyperspectral imaging, polarimetric analysis, and how they're rewriting the rules of inspection. First up, hyperspectral imaging. Think of it as a supercharged microscope for light. Regular cameras see red, green, and blue, but hyperspectral sensors split light into hundreds of narrow wavelength bands, like a rainbow with 1,000 shades. This lets them see chemical fingerprints. For example, water absorbs specific infrared wavelengths, so a drone could spot hidden leaks before they become disasters. But here's the catch. For these readings to be accurate across different devices and times, they need absolute calibration, like making sure every sensor agrees on what blue really means. Miniaturizing this tech for drones is a game changer, but it's not easy. Hardware limits mean we can't always get perfect data. Enter computational magic. Sophisticated software now turns these constraints into advantages. By modeling how light interacts with materials mathematically, researchers are turning drones into portable labs. Imagine a drone scanning a building, not just taking pictures, but revealing hidden moisture, material decay, or even biological contaminants, before they cause costly damage. But wait, how do we get even more info? That's where polarimetric imaging steps in. While hyperspectral scans chemistry, polarimetry deciphers surface physics. Light doesn't just bounce off surfaces, it gets polarized or aligned in specific directions. By analyzing how materials alter this polarization, we can measure things like surface roughness, stress, or even depth in tricky environments. Think of it like a fingerprint for light. Smooth surfaces keep light's polarization intact, while rough ones scatter it. This lets us calculate metrics like the linear polarization ratio to assess material condition. And it's not just about surfaces. Polarimetry can reconstruct 3D shapes, even for reflective or textureless objects where traditional cameras fail. Now here's where it gets really cool. Combining hyperspectral and polarimetric data into spectropolarimetric imaging. This fusion is like giving drones a superpower. For example, while hyperspectral might spot water via its absorption bands, spectropolarimetry can reveal how that water is distributed, whether it's pooling in a corner or seeping through a crack. Together, they create a full picture of a structure's health, like a medical scan for buildings. But here's the real kicker. These drones aren't just passive sensors. They're learning systems. By pairing this data with AI and ROS2, the drone equivalent of a nervous system, they adapt in real time. Want to check for mold in a basement? The drone translates that command into action, scanning hidden areas with precision no human could match. It's like having a robot assistant that gets smarter with every mission. From agriculture to disaster response, this tech isn't just futuristic, it's here. Drones are becoming smarter, more precise, and more vital. What's your take? Drop a comment, let's discuss the next big breakthrough. Thanks for watching. The future isn't just coming, it's flying right at us.